Okay, so this is the first lesson on our new unit on fixing position, and what we're going to start off with is a cross-bearing fix. So there's about 5 parts to the question that we're going to have a look at, but first of all, let's think about what a cross-bearing fix is. It's something that requires at least 2 objects, ideally separated by about 90 degrees. The navigator will note the bearings of 2 or 3 landmarks that are noted on the navigation chart, and they will convert them to true bearings and then mark them off on the chart. The intersection of these lines becomes the cocked hat. That's the circle with the line in the middle, or the dot in the middle, looking a bit like that. And then the time is noted at that point. So let's have a look at this problem. At 10:30 a.m., the yacht Lady Jacqueline records a bearing of a church steeple at 70 degrees true and an aerial at 105 degrees true. At 11:15 a.m., the bearing of the church 95 degrees true and aerial 200 degrees true are noted. So we need to use this information first of all to fix the vessel's position at these times. I'm going to then ask you to tell me how far the vessel has travelled in this time, calculate the speed of the vessel in knots, determine the true bearing of the vessel, and determine how far the vessel is from the church at 11:15. So let's look at 10:30. So what we need to think about are the bearings: 70 degrees true from the church steeple and 105 degrees true from the aerial. So let's determine the vessel's position. So remember to place your protractor on the center point of the, in this case it's the church steeple. We need to make our protractor face north, so that's 0 degrees, facing directly up in line with true north. We now need to mark the angle. Now that's that little dot that appeared there at 70 degrees. We're going to draw a line through from that little dot there through the center of the protractor, just out somewhere. So we know that the vessel's got to be somewhere on that line. And we're going to use the bearing from the aerial to determine or to fix the vessel's position. So we're placing the protractor on the aerial. We need to consider it's 105 degrees true, and then we're going to draw that line. Now we draw that little circle, that's our cocked hat, and that's the vessel's position at 10:30. But now we've got to do the same for 11:15. So for 11:15, same sort of thing, but let's note the change in the bearing. So the bearing of the church is 95 degrees true. The bearing of the aerial is 200 degrees true. So protractor on top of each of those points. So the center of the protractor is directly on that dot. Let's mark off on the side, so 95 degrees. There's our line from the steeple. There's our line from the aerial. The intersection of those 2 lines becomes the fix, or that's where the vessel is at 11:15. So there's our time, there's our cocked hat. The next part of the question is to determine how far the vessel has travelled in this time. So we need to connect these 2 positions. So the vessel has moved from 10:30 to 11:15. It's moved a little way there. So we'll draw in that line. That's that dark line there, and we now need to measure that distance. So you need to use a ruler. You could use dividers, a piece of string, a side of a bit of paper, anything, because you just need to figure out the straight line distance and then put it on the latitude scale on the side. Now, to make things easier, I've put my 0 just against the whole number of the scale, and that makes it so I can just count straight down, remembering 1 minute which of 1 degree, that much there, is the same as 1 nautical mile on a great circle. So I've moved from that much, so I'm just counting 1, 2, 3, 4, 5, 6, 7. Now looking here, there are smaller markings, but there's only 5 smaller markings within that minute or nautical miles, and it takes up 4.5 of them. So one small one would equal 0.2 of a nautical mile, and 4.5 would be just 0.9. So we've travelled a total of 7.9 nautical miles. The next one is to calculate the distance. Now we know the distance and we can quickly work out the time. We've got travelled from 11:15 and 10:30, so that's just a difference of 45 minutes. Now our answer is going to be in knots, which is really nautical miles per hour. So when we think about this, we need to consider time to be in hours. We've worked it out to be in minutes, so just remember to convert that through. 45 minutes is 45 minutes over 60 minutes in an hour, so 45 over 60, or 3/4 of an hour. You may want to convert that through to 0.75 to be a decimal version of 3/4. Now we just need to substitute in distance and time to calculate the speed. So remember, the formula for speed is distance divided by time. We know we've travelled 7.9 nautical miles, and we've travelled a time of 45 over 60 hours. So I'm just substituting in those numbers, and I am calculating that to be 10.53 knots, or 10.53 nautical miles per hour. The next part of the question is asking you to determine the bearing of the travel. So remember, we started at 10:30 and we're going to 11:15, so we're traveling up in this direction. So what we want to do is place our protractor on the path, so the center of the protractor anywhere on that path, with 0 degrees facing true north, and then we're just going to read in a clockwise direction from 0 to here, and that works out to be at about 51 degrees true. The last part of the question is going to ask you to determine how far the vessel is from the church at 11:15, and we've done this already. All we need to do is to consider the distance from the church steeple to where the vessel is at 11:15, so it's about there on my ruler, 7.5 centimeters. What I want to do is just measure that off on the side scale, and that works out to be at about 4.6 nautical miles. And there you